Hello friends and welcome to Sarat Chandra IAS Academy where your dreams are our mission. This is Yatharth here and today we are going to talk about decarbonizing the steel sector. So let's see what is this all about. This is the article from where I have taken this context. So decarbonizing the steel sector will pay off. So let's see what are the terms mentioned here. So accelerated shift to cleaner production methods. So when we are talking about the shift to cleaner, and third we are talking about the production methods. So this all we are talking in context of the steel. So it will help save huge amount of forex. That means somewhere it's related to import and economy. Alright, and make India a supplier of green steel. So another important thing we are talking about is green steel. That means it is related to climate change also. Alright, this is why this topic becomes very important. Okay, so when we are talking about the cleaner, we are simply talking about the greener steel. In the same way, you can read about the green hydrogen also. It was very much in news recently. Alright, so we are talking about the shift and production. So let's first understand and see what is steel. So this is our first topic, that what is steel that we are going to talk about. Okay, so steel is basically iron. The base is iron. Base means 95% to 98% it's iron. And some of it, such as let's say 2%, 3% is carbon. So iron has metallic properties. It's a metal, inorganic substance. And carbon has organic properties. It's a non-metal also. So it gives certain different properties to this steel, which is an alloy. So they are mixed at high temperature. So the physical and chemical properties change, and very especially the physical properties change. Such as, let's say, tensile strength, malleability, alright. Other, let's say, the complete structure, internal structure of the cross section. So many things change. The bending power, the elasticity coefficient, many things change. So that's why steel becomes much more useful than its base, which is iron. And steel is the largest produced commodity in the world also. Largely used in the construction sector. There are many different types of steels. Further, let's say we add iron plus carbon plus chromium in it, then it becomes stainless steel. So it also protects against rust. Rust is a chemical phenomena, please remember. The oxidation of the, let's say, outer layer of the iron gives us rust. Okay, so this is what was steel, or what is steel. Let's now see that what is the context here, what we are talking about. So steel is one of the core pillars of today's society and one of the most important engineering construction materials. So however, just a second. So however, the steel industry is among the three biggest producer of carbon dioxide. So very naturally, if we are mixing carbon, then we are not talking about the carbon that is eventually getting mixed, because it has gone inside the material. It has been trapped inside the material. We are talking about another carbon that is being released in the air in this method, in this production method. All right. So consequently, steel players across the globe are increasingly facing a decarbonizing challenge, or basically say pressure, to reduce its carbon footprint from both environmental and economic perspective. So we talked about both perspectives, such as shift to green plus economic means lesser imports, exports, etc. Okay. So India is currently the world's second largest steel producer after China. So please remember this fact, this premise. Various analyses show potential for multifold increase in steel consumption by 2050. So of course it's related to the population. More population, more needs, and one of the need is the shelter. That leads to more construction, and that leads to more steel being produced and consumed. So production of steel in India is set to increase significantly over the next few decades to meet the increasing domestic and international demand. Decarbonization of the steel sector has a big role to play in emission of low carbon India as an essential ingredient for the country's green future. All right. Now let us simply see that where is steel produced in India? What is the current scenario? What is the current scene? So major producers will be, one is Odisha, the first is Odisha. The second is Jharkhand. Third is Chhattisgarh. The fourth is Karnataka. Fifth is Maharashtra. Sixth is Gujarat here. And seventh is West Bengal. So as you can see, this region is quite rich in production. All right. Other things are, here you can see the states and specific centers also. It's a better map. Or you can just search on Google for the same thing, that steel production in India. Just remember that this eastern sector, especially Odisha, Jharkhand, Chhattisgarh, West Bengal, Karnataka. So these are the special producers or leading producers. So let's talk about the current or present scenario. So steel is a key sector in Indian economy, and it's responsible for around 2% of the country's GDP in last year, financial year 21-22. We are talking something that contributes 2% in everything that our GDP offers. And India is currently also second largest producer of the crude steel and second largest consumer of the finished steel. So we are exporting also. All right. The national steel policy was devised in 2017. This is also an important fact. And it has set a target to reach 300 million tons of annual production by 2030 from the existing level of 120 million tons. So 120. So this is a 2017 thing, please remember. What is the aim? Aim is to reach 300 million tons. All right. 1 ton is 1000 kg and 1 million is 10 lakh. So total overall it adds to 300, and so these many kg per year. All right. So as the economy grows, Indian crude steel production is expected to increase to about 435 million tons by 2050. Now let's talk about the emission. So direct emissions. So what are direct emissions first of all? So excluding emissions from purchased electricity use from iron and steel production stood at approximately 270 million tons of CO2 equivalent. 270 million tons of CO2 equivalent in 2018. And that comprises almost 9% of the total greenhouse gas production of the country. So something that is 2% of the GDP is responsible for emitting 9% of the GHG. All right. So steel contributes almost one third of the direct CO2 industrial emission, or 10% of India's total energy infrastructure of CO2 emissions, and about 11% of countries' total emissions. So 11% of countries' total emission. This is the thing that you should remember. All right. So what is the significance? Why are we doing this of decarbonizing the steel sector? So one thing in economic way, forex saving of approximately 5%, 500 billion US dollar would occur by 2050 from reduced spending on coking coal alone. What is coal? Coal is used in furnaces where high temperature is required in order to make steel, melt iron and mix carbon in it. All right. So a greener steel industry can enable India to be a global green steel manufacturing hub also. Other things, decarbonizing the steel sector is also important from the perspective of emerging regulatory landscape internationally. So EU has recently launched a new rule, the CBAM. What is CBAM? It favors basically the domestic green steel industries, and its name is Carbon Border Adjustment Mechanism. So you can read about it. It's a very different and separate topic. So we are not going to cover here. Just read about CBAM. So let's see what are the initiatives to decarbonize Indian. Just a second, I'll cover it here. So one thing is National Green Hydrogen Mission. National Green Hydrogen Mission. So you can read about this. Second thing, this also promotes the promotion of the green steel. Green hydrogen is very much in news and very important topic. Other thing is steel scrap recycling policy, that is of 2019. Steel scrap recycling policy. Third thing is a national solar mission also. So this promotes the use of solar energy and also helps reduce the emission of steel industry. Two more things are there. One is industrial deep decarbonization initiative. So this has been launched by the Clean Energy Ministry. So it stimulates global demand for low carbon industrial materials, including steel. And there is one more thing, one more initiative. It's known as Fairesta. So what is this? It is a Kalyani Group's first green steel brand. So this can also be asked in state level exams. All right. So let us see what are the challenges to this sector, decarbonization. So there are two basic steel production routes. One is the blast furnace method. So in the blast furnace method, the primary fuel, let's say, is coke, or the form of coal, crude coal. And another method is DRI, that is direct reduction iron method. So here the fuel can be coal or natural gas. So this emits more CO2. And India uses this blast furnace method in 90% of the production. So this is the issue here. The fuel that are being used is the issue here. So what can we do? So hydrogen has the potential to fully replace coal or gas in the DRI process. So we can opt for the DRI process and replace coal with hydrogen or green hydrogen. But what it will do eventually is to increase the input cost. So every sector must grow together in order to make it feasible. All right. So green hydrogen can be produced for this. Another thing is scaling up. Let's say challenges in scaling up net zero technologies. So what the first is cost. So cost is the biggest economic hurdle here. So global estimates suggest that the investment for setting up a DRI steel plants with upstream green hydrogen generation, this method could reach up to rupees 3.2 lakh per ton of the production. So that's a lot, and we are unable to do this right now. Another thing is, right now the cost of green hydrogen is 300 to 400 rupees kg higher than the cost of grey hydrogen, that is 220 rupees per kg. So it's almost over 650 rupees per kg. So that's a lot of difference, 200 to 650. So this is also an economic burden. Another thing is this carbon capture and storage thing. that carbon, even if it's emitted, it can be captured and stored. So this is also very economically harsh on the system. There is no supporting infra at of present. All right. So let's see what can be the way forward from here. So introducing CO2 pricing and rapid development of hydrogen, green hydrogen especially. So we have to progress technologically, because we are talking about the shift here. So we have to shift from coal, coke towards green hydrogen, blast furnace systems to DRI methods. So that's why we need to be technologically advanced in order to do all this. So one is research and development, and introduction and calibration of CO2 pricing is next few years will encourage investment in low carbon technologies and accelerate adoption of hydrogen based steel making. All right. Another thing is policies for material efficiency. So one thing is scrap based steel making has the lowest carbon emissions. So this steel scrap which is produced, this can be used as per various different policies. And India relies on the scrap imports, which will become a challenge in the future as quality scrap demand increases globally for steel making. All right. To scale up domestic scrap based steel making, policies incentivizing scrap collection and recycling would need to be implemented. So there has to be a policy change. We read the similar thing about the quantum mission also. So this is a very common thing which you can write in all answers, that policy change is required, political will is required. Okay, one thing is encouraging green steel consumption and end use. So government is already doing this. Just a second. The government is already doing this. It shall set up targets for embodied carbon in public and private construction and in automotive use. So this will support creation of domestic green steel markets for domestic steel makers. So if government makes mandatory that such and such steel will be used in, let's say, cars or new electric vehicles produced after a certain year, then it can become a, let's say, positive factor for the industry, because the end user will be paying for this now, whoever has to purchase. So industry will also start producing this thing. All right. Let's now see investing in carbon capture, utilization and storage, that is CCUS. So we can capture the carbon that is being emitted. So it's currently expensive but important lever for reducing emissions. So what we can do is more research and development in this field also. So efforts are required to reduce carbon cost, capture cost, beside creating hubs in steel production center like in Odisha and Jharkhand. So these states can be prioritized for these systems, implementation of these systems. So why we need to read about this whole topic is because it's closely related to the green fuels. Because we are not talking about the steel sector here. We are talking about the fuel that is used to make steel and the carbon that cannot be captured right now. Why we are talking about the sector? It's because it's major 2% of the GDP, 11% of the emissions. So that's why we are talking about it. So just focus on the fuel, focus on the green hydrogen, focus on the implications of using coal and coke, and focus on how much steel is imported or exported from India. So this is one thing you can read. This was today's lecture. I hope you learned a lot from this lecture. I'll see you in the next meeting. It's Yatharth here signing off. Keep studying, keep growing, and see you again.